Hey. Oh, wow, this is loud. Yeah, thanks for coming, especially in the bad weather. I would have stayed at home. But since I'm here, I'd like to talk about this, faster than C, parsing binary data with JavaScript. A little bit about myself. I used to be a PHP developer, but the dog just ate PHP. Like a little PHP toy elephant. It was funny. So I don't do PHP anymore. Don't work with Cake anymore. I was a core contributor there. I'm now doing a startup called Transloaded. And we were initially writing this in PHP, but what we were doing was kind of awkward in PHP. Basically, a lot of our code was just spawning other programs, FFmpeg or ImageMagick, to do conversions. And we wanted to get real-time output from these processes, like progress information on how much encoding we got done from FFmpeg. And doing kind of non-blocking process spawning in PHP is just the most terrible thing you can do to yourself. And so when we saw Node.js, we were like, oh, this is so much easier. You just fire up a new process object and you get events on it, and it was amazing. What was not so amazing was that when we found Node.js, it was really young. I was like number 24 on the mailing list, so Node.js was not a thing back then. And so using Node.js that early actually meant working on Node.js a lot instead of what we were actually trying to do. So by necessity, I kind of became a core contributor and ended up doing a lot of patches in the Node core. I don't do too much on the core anymore, but I still do a lot of modules, NPM stuff. Anyway, has anybody heard about Nodecopter? Nobody has heard about it. It's something else I do that I want to just quickly mention. We started an event in Berlin called the Nodecopter. We were only planning to do it one time, and basically we got 60 people together for one day to program flying robots in JavaScript. So if anybody wants to hear about flying robots in JavaScript later on, I have a flying robot here, and I think you guys have JavaScript. So if you want to play with this later, just let me know. And otherwise, just go to nodecopter.com later and check it out. We have videos and photos, and we're organizing more events, possibly one coming up in Prague as well. All right, so let's get into this talk. So this talk is about one of the NPM modules I wrote because it was not available. In specific, I wrote a MySQL module called just MySQL. And I wrote this module in pure JavaScript. Instead of binding to something like libmysql or another implementation of the protocol. And this talk is kind of about a little bit about a performance battle I've been having with a few guys on GitHub on this particular module. So this is kind of JavaScript versus C for performance. So I like to think about it as good versus evil. Or maybe it's a good parts versus evil at least. Turns out, if you want to get the best performance, you also need the bad parts. We're going to talk about that in a bit. So, am I going to try to convince you at the end of this talk that JavaScript is faster than C? No, that's a title bait, and I'm sorry for that. But what I am going to try to convince you in this talk is that JavaScript can be as fast as C for writing database driver bindings, for parsing binary data. So if you choose between writing something natively in JavaScript or writing something in C for performance, if you're going to bind it to Node.js anyway, you're probably going to be as fast in pure JavaScript as you will be with the C binding. And I'll get into the details. Anyway, so let's get this story started. In early 2010, there was a problem in the Node community. There was no MySQL module for Node.js. Node was taking off a little bit and people were getting interested in it, but like every 2 or 3 days somebody came to the mailing list and was like, hey, where's the MySQL module? And we were like, we don't have one. The problem was that most other languages just simply were binding to libmysql, which is the C library that ships with MySQL, to do the parsing. But in Node.js, we couldn't really do that because the libmysql library is blocking. So whenever you call a function on it, it will stop your program. And in Node.js, that means your whole program is stopped. Nothing else is happening because it's single-threaded. We later on figured out how to work around this by basically running these blocking calls in a separate thread pool and then joining into the main thread and getting all of this working. But in early 2010, that was not in the core, and we were not quite sure how this would work. And this kind of changed when this guy came came along, Masui Drive. He's this Japanese guy, and in his like super polite Japanese way, he posted to the Node mailing list, contributing a patch to the core, and then he was like, by the way, I've also started working on the MySQL module for Node.js. And it was like a little thing on the end, and everybody was like, whoa, and he got like 20 replies, everybody really excited. I don't know if his patch was actually getting any attention, but so I was one of the people who also looked at his module. So I went to GitHub, checked out his code, and I was pretty impressed that he did a MySQL module when I read it. But what was even more impressive was that when I looked at the code, I just saw pure JavaScript. There was no C or C++ in there. It's pretty crazy. What was more crazy was that this was before buffers became usable in Node. If you're not familiar with buffers in Node, it's basically an object that holds binary data. So he did not have buffers. All he had was strings. So his MySQL parser, and MySQL is a binary protocol, was using JavaScript strings. And that was really crazy. By the way, a little piece about of Node.js trivia. How many of you know that buffers used to be called blobs in Node.js? Okay, you had no chance. They were named blobs for 3 minutes and 15 seconds, and then Ryan was like, oh, I like buffers better, and he reworded the name and changed it all. I think he shouldn't have done that, because sometimes I talk about buffering data, but I may not mean binary data. I may just mean pushing something into an array and letting it grow, or concatenating a string. So blobs would make that much clearer. I could say blob, and people would be like, ah, binary data. But, well, the blobs are dead. So rest in peace, little blobs. You're going to be missed. Your short life. Anyway, so back to the main thing. When I was looking at his module, I basically realized that MySQL can be done without libmysql. And this may seem terribly obvious in hindsight, but it was not, nobody considered to do this because it's a crazy amount of work and very difficult. And Ryan Dahl himself didn't consider anybody doing this. So everybody was like, oh, we can do this in JavaScript. So unfortunately, Masui Drive never quite finished his module, and then Node had buffers. And so any good module would use buffers after they became available. And so he didn't do the work, so I basically stepped in and created a new module based on buffers called Node.mysql. And it took me longer than I thought it would take me to do this. I think I spent about 3 months getting a good first version out of the door. Not full-time, but a lot of time went into it. And instead of working on my actual startup thing. But anyway, so I ended up finishing it, it ended up working, people started using it, life was good, but no good deed goes unpunished, right? And there's actually scientists that you may know that kind of puts this on solid scientific principles. His name is Sir Isaac Newton, and he discovered that no good deed goes unpunished. But being a scientist, he gave it a fancy name, so he called it the third law of motion. And the third law of motion basically says, when the first body exerts a force F1 on a second body, the second body simultaneously exerts a force F2 equals minus F1 on the first body. This means that F1 and F2 are equal in magnitude and opposite in direction. Cool. So Isaac Newton, unfortunately, was a guy who was very competitive, and he didn't publish all of his work right away, and then he got into this dispute with Leibniz about who invented calculus first. And obviously, this could not have happened today, because today we have GitHub, and he would have just pushed his stuff to GitHub, and he would have the Git timestamp, and you could prove who it is. So I'm pretty sure Isaac Newton today would be on GitHub, and he would be a better man for it. But so assuming that, I mean, I'm obviously crazy because who knows what he would be, but assuming he would be on GitHub, maybe he would be involved in finding some stupid shit like the third law of GitHub. And so the third law of GitHub could be when a first person pushes a library L1 into a remote repository, a second person simultaneously starts working on a second library L2, which will be equally awesome, but in a different way. That's why we love GitHub, right? GitHub is awesome because it's just, you do something cool, other people do even more cool stuff, and we have a lot more open source for that. But sometimes it also hurts. Sometimes you try to do something really well, and then somebody just pushes something out in the public, and it makes you look really bad. And all your work kind of seems like shit. And this is what Zanis did to me. I recently had the chance to meet him in Italy, great guy. Anyway, so what he basically did is, after we figured out how to do blocking system calls in the Node.js core, he created a library, an add-on called Node.mysql libmysql client, which is what the name says. It's a C binding to libmysql, and it basically means he has to do a lot less work. He just needs to write a JavaScript wrapper. What he also did is, he created a benchmark. And I also did some benchmarks of my own. Here's one example. I created a benchmark where I was parsing 180 megabytes of network data coming from a MySQL server. So that's 100,000 rows in this 180 megabytes. And there's 5 columns in there. ID, title, text created, updated, could be a blog post or something. And basically the work the parser has to do is the parser has to create 100,000 JavaScript objects, one for each row. And each row has 5 keys and 5 values. So the total amount of objects being created here is 100,000 objects plus 500,000 keys plus 500,000 values. So that's kind of the workload. So I ran this benchmark against his parser, and unfortunately my implementation's on the left side. So that was bad. He did a lot of work, but I mean, I re-implemented the protocol. He just goes and uses a C library, and it's so much faster. And I was like, well, of course. libmysql is written in C, and my library is written in JavaScript. And C is fastest than JavaScript. We all know that, right? It seemed like the absolute truth to me. So I got really depressed for a while, kind of stopped working on the module, and I was like, I guess doing this in JavaScript was a bad idea. Shouldn't have done that. But I kind of kept thinking about it. I mean, I've heard all these things about Node.js that make it so great, and I was like, V8 is supposed to be fast, right? And it's supposed to have this crankshaft thing, which analyzes your code as it runs and then optimizes it and produces even better assembly code. And I mean, Node.js itself, it's supposed to cure world hunger and everything there is. Was I living a lie? Was it like bullshit? So, well, the truth is kind of, yeah. Because V8 and Node are tools. And from doing a lot of performance work, there's one thing that I kind of learned, and that's performance is not a tool. It's not like you download something, install it, or bind to it, and suddenly you get performance out of it. That's just not how it works. If you've done a lot of performance work, maybe you agree, maybe you don't, but to me it seems like performance is more like hard work and data analysis. So basically there's no silver bullets. Tools can help, but some problems are just simply not solved by adding a few lines of code and making things go faster. So what I basically did is, to make my library faster, I sat down and I just retried everything. I rewrote the library from scratch, and I tried to find out what makes it go fast. And so there was actually first attempt that was an utter failure. I had this crazy idea for a design, turned out to be 1,000 times slower. That was bad. But then I did a second one and kind of simplified it a lot. And this simplification helped me get a lot faster. And so this time my library is actually on the right side. So I was like, yeah, JavaScript, fastest than C, like amazing. I was really proud of myself, and so I created this talk and I submitted it to some conferences, and it was like, I wrote a JavaScript MySQL driver that's faster than C, ha ha ha. And well, I think the third law of GitHub thing is really real, because what happened, another guy came along, Brian White, and he created yet another module on GitHub. Just when I made mine a lot faster, he created Node MariaSQL. So MariaSQL is a MySQL client that comes with the MariaDB, and MariaDB itself is a fork of MySQL. What makes the Maria or libMariaSQL faster or better than libmysql or more compatible with Node.js is basically that they added non-blocking sockets to it. So it actually fits a lot better with the way Node.js works. You don't have to spawn another thread to make something happening for each query. And additionally, Brian really knows how to do these bindings well. So the end result, I did my benchmark again with this. This time my module is not on the right side again. So yeah, I was really upset, understandably. But anyway, so do you guys think this is time to give up? No. All right, never. So I kind of sat down and created a new parser. And this is kind of unfinished stuff because sometimes I do actual work instead of just fantasizing about parsing MySQL data. So the new parser here is this time minus on the left and the new parser is on the right. So the old and the new one. And it looks like I'll be able to get a 2 times performance speed up again on my current parser. And I'm going to talk about how I get there in a bit. And at that point, I think that I'll be at the same speed as the Maria SQL. I don't have a benchmark yet that compares them directly because this one has not been integrated with the networking layer. But I'm pretty sure it's going to be like within 10%, maybe minus 10% slower, maybe 10% faster, but in the same ballpark again. So anyway, is it even worse to do this work? Won't the third law of GitHub kick in? And as soon as I make this commit and push it out, somebody releases an even faster parser. I thought about this, and I kind of think the answer this time is no, because I think we are approaching the end game. And the end game is that the last bottleneck is becoming V8 and creating JavaScript objects. So no matter what the parser is written in, at some point the parser has to go to V8, either by being JavaScript itself and just creating new objects, or by being C++ and asking the V8 API to create a new object. But it has to go and be like, hey, I need 100,000 JavaScript objects, and they need to have 500,000 keys and 500,000 values. So there's real work that the V8 engine has to do, no matter how the parsing is actually done. And so from what I can see in my current benchmarking is that this is the main bottleneck. Right now, really just the pure creation of JavaScript objects is where the problem lies. So no matter how much faster the parser would get, it would not make the end result any faster. And of course, the V8 guide could go and optimize V8 even more, and that would make that battle continue. But I think V8 for some stuff is already close to optimal performance that a JavaScript VM can have. Also, there's another thing that kind of doesn't survive this endgame, and that's the MySQL server. So in those benchmarks I was showing, the parsers are able to handle about 6,000 megabits of data that's on a single connection from a single client in a single process. So a machine with 2 cores could max out a full MySQL server on a 10 gigabit connection, even if the MySQL server could saturate 10 gigabits, which I don't think most MySQL servers will do on a realistic workload. So I think this is, like the end result of this performance thing is that writing database drivers in like deciding if you should write database drivers in C or JavaScript or replace JavaScript with any fast dynamic language, you can probably consider that a solved problem. If you do the work really well, you can write, you can use JavaScript or C to do the parsing, it won't matter. You're going to be bound by the object creation, by the serialization. So anyway, how did I get there? How does one write fast JavaScript? Before I get into this, let me talk a little bit about what doesn't work, because I tried a lot of things and some just didn't work. One of these things was profiling, because if you're doing something and you already try to optimize it, you kind of know which function is kind of generating a lot of the processing time. So when the profiler tells me my parse function is slow, I'm like, duh, like this is not really helpful. I knew that. Maybe it will tell me parse row is slow. I'm like, oh, wow, I did not see that coming. So profiling is really good if you don't know what function is slow, but if you already know that, profiling really sucks because the profiler is really bad at telling you how to fix it. It's just going to say, this function takes all your time, and if this function itself doesn't call another function that shows up, if it's just like the primitive JavaScript operations you're performing, then the profiler is just that's the end of what the profiler can do for you. So if you're going for something really high performance, the profiler is not going to get you very far. Another thing I should mention is taking performance advice from strangers doesn't work. And as far as you're concerned, I'm a complete stranger. So you should not actually listen to anything of this, any of the specifics. And by specifics, I mean talking about stuff like if arguments.lengths should be taken outside the loop, or using exceptions, or anything specific. Like, ignore all that advice. Because all it is, it's good for ideas and inspiration. When you have something that's slow and you want to make it faster, you can remember these things while you run a benchmark and be like, maybe this helps. Then you try it out and you see if it helps or not. And what you're going to learn is that it really depends on context. Some stuff that makes a lot of sense for micro benchmark, where you're just testing this one feature, does not make sense in your workload. It's maybe not being the hottest part of the function. So optimizing your code for the VM makes no sense at all. In general, you should never do that. You should always try to write clear and simple code. So when you feel forced too much to optimize for the VM, maybe you need to rethink your design. Also, taking performance advice from strangers can lead to even more terrible results when you do it on a macro level. So one of the mistakes I made in my very first MySQL module is I hadn't written a binary parser before. So I was like, let me look at some other binary parser. Actually, not even binary, just some other parser. How does this work? And so I looked at Ryan's HTTP parser, because that thing is supposedly awesome. It's really, really fast. It's written in C. It doesn't buffer any stuff. So it takes like 50 bytes of memory for parsing an incoming MySQL or incoming HTTP connection. And every time it has processed some data, it calls a callback right away. So it doesn't buffer or hold on to any of the data. So I was like, wow, this must be the way to go. This must be how you write parsers, because this thing is fast. Ryan kind of knows what he's doing. So I basically applied the styles that he was using for his parser to my parser design, which basically ended up being a huge switch statement, like a state machine, which was a natural parser design. But actually turns out it's a terrible idea for performance in JavaScript, and especially when you're not benchmarking it for what you're doing. So it was one of the things, having this huge switch statement that ruined my performance, because I took performance advice from strangers. So here was that other example I already alluded to. So for example, if you're looping over, you're doing a for loop, some people will recommend to change this to this, because supposedly it's faster. Well, for a while it was faster. Now the V8 guys have optimized it away, and I think you're not going to see any difference. But the point is, this is the exact advice that you should ignore, that you should not listen to. Do your own benchmarks and see what actually happens under your workload. So what does work? So I've really only found one thing that consistently produces results, and that's benchmark-driven development. And benchmark-driven development is basically similar to test-driven development. You only use it when performance is an explicit design goal. So if you're just writing something to get it to work, to get correctness first, don't use benchmark-driven development. It's only if you want to battle people on GitHub, on like JavaScript versus C or some craziness, because it's a lot of additional work. But what you basically do is, just like with test-driven development, you start by creating a benchmark. That's basically what I did when I made my parser faster. I started with a benchmark, and then I benchmarked, or then I implemented the least amount of code that I could, so it would do some of the work required to parse the MySQL protocol. In my case, that was parsing the headers of the packets. So MySQL has its own packet framing, so you get 3 bytes that tell you how many bytes are going to follow in this packet. And so I basically just parse these 3 bytes, and then there's also a sequence number, that's 1 more byte. And I parsed those 4 bytes, and then I skipped the remaining packet data and just went to the next packet. And so I just wrote a benchmark that tested this, and I experimented, how can I parse these headers the fastest way? And I changed my code, saw what the benchmark did, changed my code, saw what the benchmark did, until I came to the point where I was like, yep, this is probably the optimal way to parse the MySQL headers, and I moved on to the next problem. And I kept tweaking my code. And unfortunately, there's really no better way to do this, because you're not going to know what is faster until you try it. For a lot of these things, especially when it's context aware. So if you want to do this yourself, the simplest way to do it is you just create a benchmark function like this. And ideally, well, you start empty, because then you're going to perform and see how fast you can call that benchmark function in a loop, which probably is going to be 0 milliseconds. So you start creating this loop that runs your benchmark. You take the time, you run the benchmark function, and you output the duration in milliseconds. Don't use any fancy benchmarking frameworks. They suck for multiple reasons. I'll go into it. But what you should do instead is make sure that inside your benchmark function, you end up doing enough work so that it shows a duration. And by shows a duration, I mean makes that benchmark function so it runs for more than 100 milliseconds. That may mean that you need to do a loop inside your benchmark functions that does the repetitions. But don't call your benchmark function in a for loop. Do that inside the benchmark function so you stay as close to what you're testing as you can. And then, as I said, you implement a tiny part of your function. Like I said, the parsing the MySQL headers. You look at the impact, you tweak the code, and you repeat that. So this was a really interesting approach for me, because I actually came across a lot of things where when I did my first parser, I explicitly avoiding using certain language features and didn't make certain design choices because I thought they would have a bad impact on performance. But since I was already doing this benchmark-driven development, I was like, hey, let me try it out, see if it actually matters. And so some of the things I learned for my particular benchmarking I was doing is that try-catch was okay. Having a try function wrapped around my parse function did not make it slower, or at least not in a way that I cared about it. And I always was told by the V8 engineers, if you're using try-catch, everything's going to be slow, and I'm like, not for what I'm doing. That big switch statement was bad. I found that out by testing it as well. Another thing that I was surprised is that function calls in JavaScript are surprisingly cheap. So one of the reasons I favored the big switch statement initially was because I thought, well, everything is going to be inline. I won't have to call out to other functions to get work done, so it has to be faster. Well, it actually turned out my new design makes a lot of function calls depending on the state it's in, and that is a lot faster. And another thing that was kind of unexpected but makes a lot of sense in hindsight is that when you parse binary data and you have package framing where you're being told how much bytes belong to a packet beforehand, buffering is actually a great way to optimize performance because you just wait for those 4 bytes, the header, to become available, then you read the header, and then you wait again for the whole packet to become available before you start parsing it. And what this changes in your coding is that now you can just parse straight through the entire package without having to do any bookkeeping of where you left off. So if you're trying to do a non-buffering implementation, you always need to be ready to say, hey, I only got 50% into this package, then there were no more bytes on the network, so I have to wait for more bytes. So you have to return everywhere, remember where you left off, be able to jump back into the state, and it's just a lot more work. So another thing, my favorite optimization I actually came across from doing benchmark-driven development is loop unrolling with Eval's good twin new function. So basically I'm doing Eval, and let me explain why and try to defend that it's kind of sane. So I have had this function in my code called parseRow, and it takes 2 arguments, the columns, which is an array with the column names that I'm going to receive in this row, and then the parser itself, which is basically where I pipe my network data in, and then I can just, from this internal buffer, read values off of it. And so what I have to do for each row, it makes a lot of sense, is I create a row object for each row, and then I iterate over each of the columns, and then I basically say row, column, index.name equals parser read column value, and read column value, read column value parses the actual MySQL row column, and then I return this row. So this code, the profiler told me this code is where all your time, this is where all your time is being spent. And I was like, yeah, I know, but how do I make it faster? And so I was like, oh, there's no way. But then I actually tried something. And what I tried is I replaced my loop with the static code right here. And surprisingly or unsurprisingly, this made my code another 30–40% faster when I was already working on a highly optimized version of my parser. And basically the difference in work here is I don't have to do a loop, and I don't have to dynamically assign properties to that object. So the V8 engine already knows when it enters this function what the layout of that object is going to be. And the V8 guys tell you about their hidden classes and stuff, but it doesn't work as well as this optimization does. Now the problem is that each queries that I do against my MySQL database can go against a different table. So the columns are actually not fixed. I cannot actually put this in my database driver unless I know the schemas of all the MySQL tables out there, which would be an interesting optimization. But since that was not available, I was thinking about how can I unroll this loop at runtime. Basically, MySQL sends me one package that describes the fields, and then it sends all the data for it. And so the solution is basically to use eval or new function. And what I'm doing is I create the code. I say my code is a return statement, then I loop for each column, and then I basically create this key value pairs. And then oops, I'm not good with this. And then I close my object again, and then I basically say my parseRow function that I was showing before is being evaluated during runtime. And this version is unsecure. You can make an attack in here, but you can probably see how it's easy to do the escaping, so it's not a problem. It's just simplified for the slide. Why new function? New function has another interesting property in JavaScript versus Eval. It does evaluate code, but it already puts it in a function wrapper, which is nice. But more importantly, it does not give you access to the surrounding scope. So Eval will have new function will have access to any globals, but it will not have access to any locals in this function. So it's slightly better. Anyway, it's just a fun example. Please do not remember this. Please do your own benchmarks. Because if you're already this desperate that you want to do this, you have to make sure that this is your last resort and you just want to win this stupid game you're playing on GitHub. So make sure that it makes a difference for what you're doing. Don't just be like, this guy told me to use Eval, so you write parsers with Eval everywhere. So what's the last thing you can do to up your game? Once you're already doing all this good stuff and you still want to analyze further of what's going on, you kind of need more metrics. So you need to do data analysis. And so the best way to do that is to produce, in my code example with a while loop, I was showing console log duration. So imagine this statement, but adding more values to it, tab separated. So add everything you can on a single line for each benchmark run. Add VM metrics. So V8 exposes, or Node.js exposes from V8 the heap usage, the heap total, and the process RSS, and a bunch of other metrics. Everything you can get, put it on this line and just keep repeating it for every benchmark run. And then last but not least, and this is my main problem with most of the benchmarking tools out there, do not mix data and analysis. Your benchmark should produce data. Your data goes on disk, and then you run an analysis tool on the data. If you do it the other way, if you directly take the results and you analyze them after the run, it creates a bunch of problems. First of all, you're probably not going to get the proper analysis you're looking for. And secondly, if I look at your benchmark results, I cannot go at the data and be like, is your analysis flawed? I have to read some stupid tool that somebody else wrote, which is making everything much harder to share and to compare. So recommended tools for doing the actual analysis. Well, first of all, writing to disk is really simple. You run your benchmark, and then you pipe the results in a results.tsv file. And if you want to get fancy with Unix, you can use the tutility, as I'm doing here, which basically writes to the results file, but also prints the standard out at the same time. For the analysis itself, I recommend the R programming language. Has anybody worked with R before? One person. It's a little awkward, but the language is awkward in the same way JavaScript is awkward. And this actually means you can just throw some shit at it and it will kind of be like, oh, you wanted me to draw this graph? And it kind of works. You can pick it up fairly quickly. And especially if you're using ggplot2, which is a library that makes your plots look really nice. And then I automate all of this with a few other tools. I use makefiles to automate the process, ImageMagick to convert the vector graphics. Oops, I really need to learn this. The vector graphics to PNG images, and Sketch for doing some annotations. Anyway, why? Well, the problem is that most of the time, people present benchmarks as these bar diagrams, or maybe something a little fancier, but basically it's saying A is faster than B. And the problem with this, it's bullshit. So sorry for only showing bullshit benchmarks so far. But what you need to do is you need to look at the data and see how your data points are distributed. So one way to do this is to basically randomly plot these points. And so I have my MySQL library on the left, the old parser and the new parser on the right. And the x-axis itself, besides the grouping, doesn't mean anything. It's just each point randomly distributed. But what I can see is that for both my MySQL, my old library, the new parser, I have this kind of gap in between here. The fuck? What does this mean? Like sometimes my benchmark is really fast and sometimes it's really slow. But this is the same for two different implementations that work very differently. And so I was like, this is awkward. But I have the data, I can analyze it further. So the next plot I did is I was plotting performance over time. And I saw something really interesting. After the exact amount of same iterations of parsing the same amount of bytes, both of my implementations started to have this 10% performance drop in the benchmark output. And then it kind of stayed this way. Huh, interesting. So I had more data. I also logged the heap statistics. And so one heap statistic I had is the heap total. This is basically the whole amount of memories that V8 allocates for storing JavaScript objects in. And one thing I noticed is that for both of my benchmarks, at the exact time that the benchmarks became slower, my heap went up. And V8 basically decided, I was using 20 megabytes of JavaScript, of objects allocation space so far. Why don't I use 35 megabytes now? and then it goes up to 35 megabytes and it stays there. And at the same time, performance goes to shit. So I was like, this could be memory leak, but it would be unlikely because those are two different implementations. For them to leak at the same time like this is kind of awkward. So the next thing I looked at was heap used. So this is the amount of memory V8 actually uses inside the allocated heap, which is always less. Basically, it fills up the allocation space, and then it does a garbage collection, which you can see right here. So the memory used goes up and then goes down, up and down. And basically, by not having this slope upwards pattern, but these fixed blocks where things is happening, you can kind of tell that this is probably not a memory leak. Because V8 just basically makes the mistake of allocating a heap that's too big for the workload, and then it means it lets too much garbage accumulate, and for some reason the algorithm to collect it is not linear, so it actually takes longer on the larger heap to collect it. So I felt this as a bug with the V8 team, and they're looking into it. I think it's a bug, and they verified that this is probably not a user error. Anyway, this is why it's important to do data analysis and to lock your stuff to disk and do proper analysis later on. Because if you have something like this in your benchmark, you cannot publish it and say like the bar diagram A is faster than B. You have a serious flaw in your methods, and well, if you still want to publish it, you need to point that out, and you need to do the analysis work. Otherwise, everything is kind of useless. So anyway, too long didn't read. Write a benchmark, change a little code, collect data, find problems, and go to 2. And it's really annoying, but if you do it, you get fast JavaScript. That's it. That's all I got. Thank you. I also have all the code and slides and results and stuff online.
Otázky? Má někdo? Okay. My question is, what's the point beside an exercise in benchmarking and optimizing code? I mean, it was okay to write the binding. Well, I mean, not the binding, but the parser before you could have a binding because of the non-blocking nature. But once there is a possibility to do a non-blocking binding on the C library, is there a point in continuing to maintain your pure JavaScript library?
Yes and no. No in that all I'm going to say is just my justification, because I like doing this and it was just fun. But I do have some justification. So one reason is there's value in having a pure JavaScript driver because the C bindings are not as portable. It's much harder to get, for example, working on Windows. So when Node added Windows support, Node didn't used to support Windows. My module was actually one of the only ones that was working properly. Even now, it's the one that will work the easiest across different development environments. So if you have Windows developers, OS X developers, Linux developers, my stuff will just work, where the other stuff may produce compile errors and slow things down. So that's one thing. And because people like this portability aspect, you kind of want to give them a good reason to stay with the JavaScript version. Because a lot of people will be like, oh, the C version is faster, so everybody ends up using the C version. But it turns out it doesn't mean that it's better. Mine was actually the one that was maintained the most, had the most Node.js idioms baked in, made the error handling really easy, and the other C bindings were more like the C library and the functions it exposes, and they just did not feel as easy to use in JavaScript. So there's some value in having this stuff in JavaScript, but if you want to do this, maybe don't. If you find a C library that does the work you need to do, use the C library if you have that option, if you were going down a similar route. But I didn't have it when I started out, and then it just carried on.
Okay, thanks.
Hi, thank you for the talk. I was trying to get a grasp why the parser, your function you tried, why it is actually good to do the return statement and eval it. Is it because the V8 somehow knows how much data allocate in advance? So does it actually shows that if there were types in JavaScript, it will make the performance much faster?
Well, I think so. There's so I think there were two questions. One is, why is this faster? And the second was, would this be easier for the VM to optimize the server types, right? In JavaScript. So question number one, why it's easier? I think it's easier because the VM actually needs to do less work. If it executes the loop, it actually creates the object, and then each time I assign a property, it basically has to switch the underlying hidden class. So V8 is like, okay, empty object has this hidden class. Now I add property ID. Well, we're going to this different class, which it already analyzed and knows how much to allocate for. Now I add another property, and it knows, okay, go to this other hidden class. But it each time has to do this check. Which property was added, which hidden class is this, what kind of allocation backend do I need for this? Whereas if I give it the static version, it can choose the right hidden class for this right away. So it's just doing a lot less assembly instructions. So if there were types, could it be made faster? Generally speaking, I think typed language is so much easier to optimize for people doing VMs. So I would say yes, but I also think in this particular case, the just-in-time compiler could actually do optimization here. It could see that this array becomes static during 100,000 iterations, the data doesn't change, and it could do this unrolling. But I talked to the V8 guys, they were like, oh man, we have enough work. So I don't think it's going to happen, but I think it's in the theoretic possibility to optimize this, even with an untyped language like JavaScript.
Another one, does it mean that when the heap bug you were referring to will get fixed, all your competitors will draw from that benefit also, isn't it?
Yes, but differently. So I actually, during my parsing, tend to allocate more JavaScript objects than they do, because they do their allocations in C when they do internal allocations just to get the parsing done. So they will get some of the benefits, but not all. But I looked at the benchmarks. They have a similar performance drop in similar benchmarks, but it's less than 10% as it was in my pure JavaScript versions. But they're going to see a speed up as well.
One final remark for the pure JavaScript bit. If you try to offload the work on clients, on browsers, on browsers of clients, you will be happy with pure JavaScript libraries because you can run them on the client with no, you cannot compile C on your vectors.
Oh yeah, actually, this MySQL module can run on the client. Right now, no browser implements TCP, so it cannot connect to a database. But if you were to use this in a Chrome add-on, which has a TCP backend, you could actually run this code. It needs a little modification, but for most parts, it runs in a browser, and I've done it.
Yeah, and one thing, so does it mean that Ryan should have reconsideration of the switch loop in his of some HTTP parser?
Truth is, I don't know. C is a completely different animal. In JavaScript, the switch actually ends up doing an if-else. So basically, it checks first case. If it's not the first case, it checks the second, the third, and the fourth. I think there's an optimization possibility where it just does a fixed lookup table, which I guess could also be done in JavaScript, but isn't for some reason. Maybe there's a reason, and I just don't know it. And I think C would be easier to optimize this switch statement for, because you will have the type annotation on the type you're switching on, and this allows you to build a map internally easier. So I don't know. I guess you have to benchmark it if you want to see what's fast in C.
If you are migrating from HPAP to Node, did you consider another languages like Perl or you just tried Node and you see it fits, so you use it?
No, we didn't actually try other languages. There was nothing really that had a good API for spawning other processes. If you look at all the APIs, they're really terrible. Most languages expose you at an exec function, and it will give you back the exit code or something, but never like the standard out, the standard error, the exit code, and the signal, and the PID, and maybe other stuff. I think you can get CPU time spent as well for each process. And they only expose very limited interfaces where you can get only one or the other. So Ruby, Python, Java, they all kind of, well, Java was not under consideration, but the other dynamic languages felt like they didn't have the right APIs where you get a stream back.
I think Perl can do this such a thing.
Oh yeah, Perl, but I wouldn't go there. I didn't look at Perl either. But I looked at a few standard libraries, and it just always felt awkward to get a program to execute and to treat it as a stream of data was hard. And in Node, it was just feeling obvious. So we kind of jumped into Node without, well, we considered other things, but it was just a fun thing to play with. We're building our startup. We're not venture-backed. We self-bootstrapped and turned it into a small, profitable company. So we had leg room to do whatever we wanted. Like we had to do, just means we need to do more client work to finance it. But we figured it out.
All right, thank you. My question would be, when do you think the third generation of your parser will be available?
When it will be available? When I feel the need to work on it again. Actually, I found something great out the other day, a few weeks ago. I had problems with people contributing to my modules. And like people would send pull requests, but something would be missing, like the test or the formatting would be off. And I would be like, reviewing it, be like, can you change this, this, and this, and then I'll merge. And what generally happens is they don't do it because they're afraid they do the work, and then they have to like discuss with me again, and it's never going to get integrated. And it's just, there's a lot of friction. And one thing that I started to do is I, on one of my smaller repositories, I just added somebody who was complaining or sending a patch. I just made him a contributor on the repository and gave him npm publish access right away. And I was like, so I looked at your stuff. It would be nice if you fixed this and that, but I just made you a contributor, and you can now push in and merge yourself. And the weirdest thing happened. Not only did he push and merge it in himself, as I expected, he actually made all the changes instantly. And I was like, well, that's weird. Never works that easy. So I started doing it on everything, including my MySQL module. And now I get a lot of contributions from people because, and they are high quality because now they feel ownership and they no longer think of a pull request as something they kind of push to me, I click merge, and they forget about it. No, they become a contributor, and actually they get an email every time somebody opens an issue on this project. So they actually know if their stuff is working or not. So to get back to your question, I have people who now help me with this module, and I guess if I open an issue saying like, hey, I have this experimental parser here, somebody may be able to do the work and plug it in. So hopefully sooner than later, and you just gave me the idea to kind of put it out there.